So we're going to look now at our last example with related rates. So in this problem, I'm told that a ladder 25 feet long is leaning against the wall of a house. The base of the ladder is being pulled away from the wall at a rate of 2 feet per second. How fast is the top of the ladder moving down the wall when its base is 7 feet from the wall? So here for this problem, I'm not given a picture, so we need some kind of picture going on here. So let's draw one. So let's say here I have a building, and on the side of that building is the wall, and there's a ladder that's leaning against this wall here. Here's the ground. And there I have a right triangle there. Now the only fixed numbers you should put in your picture, are fixed numbers. So the ladder is a fixed length. So I'm going to put that in. It's 25 feet. That's the length of that hypotenuse of my triangle. But then the other two sides are changing as the ladder is moving. So for these other two sides, I'm going to go with X and Y. And what I'm told, if I look back in the problem, that the ladder is being pulled away from the wall. So the ladder is moving this direction. And it tells me at a rate of 2 feet per second. So what I'm given is dx dt. Now x is increasing as I pull it away from the wall. So dx dt will be a positive 2 feet per second. And now I need my equation. So I have a right triangle here, so my equation will be x squared plus y squared equals 25 squared. And what am I asked to find? I'm asked to find how fast is the top of the ladder moving down the wall when the base is 7 feet from the wall. So I'm asked for the top of the ladder. It's going to go down like that. So I'm asked for dy dt when I'm told when the base of the base is 7 feet from the wall. So that would be x when x is 7 feet. All right, so now I've got what I need. I'm going to take my equation. The next step is take this equation here and take the derivative of both sides. So you'll get 2x dx dt plus 2y dy dt equals 0. And what am I trying to find? I'm trying to find dy dt, so I'm going to solve for that. We'll get 2y dy dt equals negative 2x dx dt, and divide by 2y. You'll get dy dt equals negative 2x over 2y dx dt. The 2's will cancel, so I'm just left with negative x over y dx dt. So now I'm going to ask myself, do I have everything I need? I have, go back to my given, I have dx dt, so I have this unit right here. I'm also told x is 7, but the one I'm missing is y. So we need to know y. So what we're going to do is go back to our equation and plug in. We know that x equals 7, so we're going to plug that in. 7 squared plus y squared equals 25 squared. So y will be So y squared will be 25 squared minus 7 squared. So I take the square root of 25 squared minus 7 squared, and if you use a calculator, you'll get y is 24 feet. So now I can solve, now that I know y, go back to your derivative formula, dy dt, it was negative x over y dx dt. So I get negative 7 over 24, and dx dt was 2, so I'm getting negative 14 over 24, which if you want, you could simplify that to negative 7 over 12. I need units again, so this will be feet per second. So here's my answer. So one thing I want to comment on is I got a negative answer for this. And if you go back to your picture, this makes sense because as the wall slides down, here, as I'm going down, y is going to be decreasing. And so dy dt should be negative. Okay.